Okay, so we begin the last part of our class today, which is on the piecewise defined functions. Can GeoGebra help us with the piecewise defined functions? So let's see. Let me share my screen again. Okay, right. Okay. All right. So, well, in GeoGebra, when we do piecewise defined functions, we actually exploit the use of logic uh, in the input line. Okay, so what type of logic operator? It's the basic if then or the conditional operator. So basically, this piecewise function just tells you that when x is less than or equal to 2, the trace of the graph of f is negative 2x plus 1. And when x is above 2, then the trace of the graph of f is that of 5x minus 4. Okay, so how do we do that in GeoGebra? Very simple. Um, okay, f of x. And then we use if then. Okay. The moment you write if, you will see there this help box, okay? But it just tells you that you first write the condition and then what's going to happen. You're basically telling GeoGebra, if this and this, you do this, okay? So our first, use square brackets, okay? All right, you can use parenthetics, okay? If x is less than or equal, okay, less than or equal to 2, okay, so again, how did I write that? First, the less than symbol and then the equal symbol. Okay, and then GeoGebra changes it to less than or equal to 2. And then what do you do? Okay, what must GeoGebra do? Graph negative 2x plus 1. Okay, and then other than that, so else you're telling GeoGebra, pero kapag hindi na siya less than or equal to 2, which is x is greater than 2, you graph 5x minus 4. And there you have your, and there you have your, okay, you have your graph. Okay. Let's just beautify this a bit. I use the color red and then uh, 8. Okay, there. So you will see now of the graph of the function f of x. Okay, where kapag less than or equal to 2cx, the trace is that of negative 2x plus 1. And if x is greater than 2, then the trace is that of 5x minus 4. Okay, and then you are asked here, is this a function? So later we will answer that. Sagutin muna natin, what is f of negative 4, f of 8, and f of 2. Okay. Very simple in GeoGebra, you just write f of negative 4. And there you go, 9. Okay, so it tells you that when x is negative 4, f is 9. Or if you want to see that as a point, then you just graph negative 4, f of negative 4. And you will see there. Okay, so let's beautify that a bit. Okay, there. All right. So how about f of 8? So f of 8, if you want, let's see this directly on the graph. Okay, 8 f of 8. What is f of 8? Okay. F of 8 is 36. 36, tingnan natin kung makikita ba natin yan. Yon. So B is now, right? Okay, so let's beautify this a bit. Let's use the purple and 8. Okay, so you will see there that at f of 8, it's 36. F of 8 is 36. Finally, what's f of 2? What's f of 2? Ah, f of 2 is negative 3. Why is that so? Because sabi natin, when x is exactly 2, we follow negative 2x plus 1. So that's negative 2 times 2, negative 4, plus 1, negative 3. Indeed. Okay, so let's plot 2f of negative 2. Sorry, 2f of 2. Okay, so you will have there, let's use green for contrast. And then, okay. Now, again, this is the limitation of GeoGebra now. It cannot show you hollow points. You should be able to tell by this time that here, okay, at 2, this is filled out, but this is hollow. Okay, this is hollow here. And to answer the question, so is this a function? Yes, because the vertical line test uh, will always hold true. That means if you drop a vertical line along this function anywhere, you will only intersect at one point. The possible candidate where the vertical line test will fail is at 2, kasi supposedly when you drop x equals to, yan, supposedly, this line will cross the function twice, here at 6 and at negative 3. But you know that since at 6 this is hollow, so safe pa rin siya with the vertical line test. And therefore, this is a function. F is a function. Okay? Right. Sir, paano kapag katulad sa learning guide, tatlo yung definitions? How do we do that in GeoGebra? Okay, let's do it. All right. So for example here, F. F is, or rather, the domain of F has three different partitions. Okay, and on each partition, there is a different graph. So how do we do that? So don't worry, you do it from left to right. So you begin with x is less than 0. So still, okay, if x is less than 0, the graph is negative x cubed. Okay, basically, you're telling GeoGebra, hey, when x is less than 0, you graph negative x cubed. And it does that for you. It does that for you, in fact. And then, what you do is you do nested if. And then you introduce another if. Ngunit, if it is less than 3, okay, so you are telling GeoGebra now, if it is less than or equal 3, so if x is less than or equal to 3, you graph 2 minus x. Okay, ayan na. You graph 2 minus x. And finally, so if it is not less than 0 and it is not less than 3, then you graph 4. There you go. So this is now how GeoGebra gives you. Okay. So you see, if when x is less than 0, the graph is negative x cubed. When x is between 0 and 3, including 0 and 3, then the graph is 2 minus x. And when it is above 3, the graph is that of y equals 4. Okay. So first to answer, so what is f of negative 2, sir? Very simple, it is 8. Okay, or if you want to see this in as a point, then you write negative 2 f of negative 2. And you will see there, hindi ko na pag-beautify ha. Okay, so you will see here that at negative 2, the value is 8. Okay. Now, supposing what is f of 0, sir? F of 0, very simple, it is 2. Okay, 2. Bakit? Because sabi natin, when x is between 0 to 3, including 0 and 3, the graph is that of 2 minus x. So 2 minus 0, that is 2. That is 2. So if we graph that, 0 f of 0, you will get 2. Okay. How about when f is 3? So what is f of 3, sir? F of 3 is negative 1. Or if you want to graph that, it's negative 1, f of negative 1. Which is, sorry, nagkamali. Okay. f of 3. Ba't ba pumasok ko? Negative 1. F of 3. 3f of 3. And you should get 3 negative 1. Again, because when x is 3 or less than 3, okay, so when x is between 0 and 3, including 0 and 3, so dyan siya pasok, what you do is 2 minus x. So 2 minus 3, that is indeed negative 1. Okay, sir, what is f of 2020? Well, f of 2020 is 4 because after x equals 3, okay, beyond x equals 3, the graph is that of y equals 4. So kahit anong x above 3, the y is always 4. The y is always 4. Okay, if you are asked, is this a function? Yes. Again, GeoGebra cannot show you the hollow points, but here, this is hollow. Okay. At 3, this one is hollow. This one is filled out. At 0, this one is filled out. And this one is hollow. Okay? So, if we drop the vertical line test, it will always, any vertical line across this function, across the domain of this function will intersect the function at one and only one point. And therefore, this is a function. How about the second example? Sige, for practice, I'll show you. Okay, so h of x is equal to, again, we use if. If x is less than negative 2, graph is negative x plus 4. And then nest. Okay. If x is between negative 2 and less than 0, so less than, if x is less than or equal to 0, then the graph is that of x squared minus 1. And finally, if x, or rather else, when it is greater than 0, you graph negative 3. All right. And this is now how your graph will look like. Okay, you will see here that when x is less than negative 2, it is that of negative 4. So, tindahan natin konti. All right, you'll see. When x is between negative 2 and 0, including negative 2 and 0, the graph is that of x squared minus 1. And when x is greater than 0, the graph is that of y equals negative 3. And we are asked, so what is h of 0? H of 0 is negative 1, or if you want to look at that in the graph, then that we say 0, h of 0, there. Okay, that's h of 0. How about h of negative 2? So let's graph negative 2, h of negative 2. There. Okay. How about 3 halves? So h of 3 halves. Okay, that's negative 3. Or if you want to see that in the graph, then you just write 3 halves h of 3 halves. Okay, and you will see that it is indeed at negative 3. And finally, what is h of 2? Okay, let's graph that. 2 h of 2. It is still at negative 3. Okay. Sir, how about at negative 2? What is the... okay, meron na pala. At negative 2. H of negative 2 here. Again, you will see the limitation of GeoGebra. You cannot see hollow points. You know that it is hollow here and it is hollow here. But to answer your question, can GeoGebra help you to do piecewise functions? Or can you graph piecewise functions in GeoGebra? Yes, with enough practice. And let me just assure you that at least in our course, we will stop with piecewise defined functions with 3 definitions. Okay, I will not go beyond 3 When I say three definitions, that means I partition their domain into three parts, just like what you see here. Okay? Just like what you see here, you have x is less than 0, x is between 0 to 3, and x is above 3. Or we can also have two. In the previous exercise, we had two definitions. We divided the domain of the function into two partitions. X is less than equal to 2 and x is above 2. Okay? This is to simplify your learning piecewise defined function, and also this is to simplify how you will uh, graph piecewise defined functions on GeoGebra. Okay? So, but I want you to practice. Please practice graphing piecewise defined functions in GeoGebra. And that's all for today, children, and see you next week.